Time feels simple. You were born into time, you grew up inside it, you never questioned it. Because you never had taught it is exactly where the problem begins. He spent years, not days, not weeks, years, sitting with questions that most people considered, already answered. I was not satisfied with answers that felt right. I needed answers that held together completely. Without exception, most did not want to take you through what I found, not to impress you, not to comfort you, but because what I found is true, and truth does not care whether you are ready for it. Begin with something familiar. You are sitting in a train, the train moves, you look out the window and you see a man standing on the platform, still from where you sit. He is moving backward from where he stands. You are moving forward, both of you are correct. That is not a riddle, that is physics. Motion is not a property of an object, motion is a relationship between objects. There is no experiment you can perform inside a sealed train car that will tell you whether you are moving or standing still. He did not invent this idea. Galileo understood it, Newton understood it, but neither of them followed it all the way to the end. He was forced to hear is why in the late 19th century, physicists believed they had nearly completed the picture of reality. Newton's mechanics were precise, Maxwell's equations for electromagnetism were precise to perfect systems, but they contradicted each other. Maxwell's equations predicted that light travels at a fixed speed, a specific number, approximately 300,000 kilometers per second, always without exception. But if motion is relative, if there is no absolute rest, then the speed of light should depend on who is measuring it. A man standing still should measure one speed, a man running toward the light should measure a higher speed. Just as a man running toward a train hears a different pitch than a man standing still. That is what Newton's framework predicted. That is not what anyone found. Every measurement of light, regardless of the motion of the observer, regardless of the motion of the source, returned the same number. Wastes was not a small discrepancy. This was not a rounding error. This was a direct and total contradiction at the foundation of physics. Something had to give. Most physicists assumed the problem was with the experiments. They searched for errors. They invented a substance called the ether, an invisible medium filling all of space, through which light was supposed to travel at that fixed speed. If the ether existed, then light's speed was fixed relative to it, not relative to the observer. That would resolve the contradiction. They searched for the ether for decades. It was never found. He took a different approach. He decided to take both principles seriously, not one or the other. Both motion is relative. There is no absolute frame of rest. This must be true, and the speed of light is constant. Every observer measures the same value. This must also be true. If both are true simultaneously, then something we considered fixed must actually be flexible. I follow the logic. If you're running toward a beam of light and you still measure that light traveling at the same speed as someone standing still, then something in your measurement must have changed. The speed of light did not change, so either the distance you measured or the time you measured, or both, must be different from what the stationary observer measured. Not because of instrument or backhouse. That is what reality is doing. Time is not fixed. That sentence took me a long time to be willing to write. I did not want it to be true. It felt wrong. It felt like a trick. Surely time, the thing that passes, the thing that clocks measure, the thing that ages our faces, surely that is the same for everyone. It is not. Well, observers moving relative to each other do not agree on how much time has passed between two events. This is not a matter of perception. It is not confusion. It is what the universe actually does. He called it time dilation. The word is technical. The reality is stranger. Clock moving through space runs slower than a clock at rest, not metaphorically onto proximate life. Moving clock genuinely accumulates less time. If you carry that clock on a journey at high speed and bring it back, it will show a smaller elapsed time than the clock that stayed behind. They will disagree. They will both be right because they experience genuinely different amounts of time. This has been confirmed. Atomic clocks placed on aircraft flown around the world returned and compared to clocks that remained on the ground. The difference is small, but it is there exactly where the mathematics said it would be. The universe does this, and if time changes with motion, so does space. An object moving through space is shorter, measured along the direction of motion, than the same object at rest, not because it is compressed by some force, because length itself, like time itself, is not fixed. It depends on the relative motion between the object and the observer. I want you to feel what this means. Length is not a property of an object alone. Time elapsed is not a universal quantity. They are both relationships. They both depend on the frame from which you measure them. There is no master clock ticking somewhere in the universe. There is no absolute ruler against which all lengths are measured. I found this difficult to accept. I kept checking the logic. I kept looking for an error. There was no error. Reality simply does not work the way we assume it. From this I was forced to drive another conclusion, one that has perhaps become the most recognized equation in human history, though I suspect most people who recognize it do not understand what it means. Energy and mass are the same thing, yet related, not proportional in some convenient way. The same to descriptions of a single quantity. A system with more energy has more mass. A system with less energy has less mass. If you cool an object, it becomes very slightly lighter. If you compress a spring and hold it compress, it becomes very slightly heavier, because the stored elastic energy adds to its mass. These differences are tiny at ordinary scales, but at the scale of atomic nuclei, they become significant when a nucleus splits. The pieces together have less mass than the original nucleus. That missing mass did not disappear, it became energy. A specific and calculable amount of energy did not discover the atomic bomb. I discovered a relationship that nature had always contained. What humans chose to do with that knowledge, that is a different matter, and one that weighed on me for the rest of my life. But let me not move away from the physics too quickly. Is something more fundamental still. Everything I described so far, the slowing of time, the contraction of space, the equivalence of energy and mass, all of this emerged from asking one question about light and motion. But I had not yet asked the harder question: what about gravity? Newton gave us gravity as a force, a pull between masses, acting instantly across space, diminishing with the square of the distance. It worked for more than 2 centuries. It worked with extraordinary precision, but I knew it could not be complete. Newton's gravity acted instantly. A change in the position of the sun, in Newton's framework, would be felt immediately at the Earth. No delay, instant. But nothing can travel faster than light. I was certain of this. It followed necessarily from everything I had already established, so gravity could not act instantly. Something had to carry it, something had to propagate at a finite speed. And there was another problem in Newton's framework. Gravitational mass and inertial mass are equal. Gravitational mass is how strongly an object is pulled by gravity. Inertial mass is how strongly an object resists acceleration. They are measured by completely different phenomena, and yet they are always, in every experiment ever performed, precisely equal. Newton had no explanation for this. It was a coincidence. In his framework, a remarkably precise, perfectly universal coincidence. He did not believe in coincidences of this kind. He believed they were telling me something. He thought about a man inside a sealed box, far from any planet, being accelerated upward. He stands on the floor. He feels weight. He drops a ball. It falls to the floor. He cannot distinguish their situation from inside the box, from standing on the surface of the Earth. This is not an approximation. This is exact. Gravity and acceleration are the same thing, not similar, not analogous. The sum of this is what I call the equivalence principle, and from it I understood that gravity is not a force at all. Let me say that more carefully, because it matters in Newton's picture. A planet orbits the sun because the sun pulls at the planet. If left alone, would travel in a straight line. But the gravitational force bends its path into a curve. In the picture I was forced to construct, The planet is traveling in a straight line, straightest possible line, but space itself is curved. Mass curves the geometry of space. And not space alone. The geometry of space-time is also curved near a massive object, and what we call the path of a planet is simply the path that requires the least, or more precisely, the extremal, proper time. It is a geodesic, a straight line in a curved geometry. There is no force of gravity, there is only geometry. This sounds like an abstraction, it is not. Light follows this curved geometry. A beam of light passing close to the sun is bent not because light has mass, not because some force grabs it, but because the path through space-time near the sun is curved, and light, like everything else, follows the geometry. 1919. An expedition observed a solar eclipse. Stars near the sun became briefly visible there. Apparent positions were measured and compared to their known positions when the sun was elsewhere. They were displaced by exactly the amount I had calculated, not approximately geometry of space near massive object deflects light. The universe confirmed this without hesitation, but there is something in this picture that I have not yet said clearly. Space and time are not the stage on which the universe performs. They are not fixed, they are not absolute, they are part of the performance. They bend, they stretch, they respond to mass and energy. A massive object does not sit inside space, it reshapes space round it and everything moving through that space, light, planets, clocks, human beings, follows pulse, determined by that sheep. Time near a massive object passes more slowly than time far from it. A clock on the surface of the Earth runs slower than a clock in orbit, not because of velocity alone, but because of gravity, because it is deeper in a gravitational well, because space-time is more curved. Their ethos is not hypothetical. The satellites in your navigation systems carry atomic clocks. Those clocks drift from the clocks on the ground. The drift is caused by two effects: velocity, which slows them, and gravity, which speeds them up because they are farther from Earth's center. Both effects must be accounted for precisely using the mathematics I developed. Without this correction, positional errors would accumulate at roughly 11 kilometers per day. The global positioning system runs on general relativity, not as a curiosity, as a daily engineering necessity. No, I want to say something that I found, and still find, deeply unsatisfying. The theory of gravity, general relativity, is extraordinarily successful. It predicts the bending of light, it predicts the precession of Mercury's orbit, it predicts the existence of black holes, regions where the curvature of space-time becomes so extreme that nothing, not even light, can escape. It predicts gravitational waves, disturbances in the fabric of space-time that travel outward from violent events rippling across the universe. These waves have now been detected directly to black holes more than 1 billion light-years away. Collided the distortion they created in space-time, smaller than a fraction of a proton's width, was measured on Earth. My theory described it correctly, and yet general relativity is not complete. There is another theory, also tested to extraordinary precision, that describes reality at the scale of atoms and smaller quantum mechanics. It describes a reality that is fundamentally probabilistic, not uncertain because of our ignorance, uncertain in principle inherently. A particle does not have a definite position until it is measured. Its state before measurement is a superposition of possibilities. He did not accept this. He spent the second half of my life trying to show that it was incomplete, that there was something beneath it, some hidden variable, some deeper layer of reality that was deterministic, that restored the clear causal picture I believed the universe must have. I did not succeed. The experiments performed since my death have repeatedly sided with quantum mechanics. The universe, at small scales, does not appear to have definite properties before they are measured. It appears to be, in a fundamental sense, indeterminate. I found this unacceptable. I may have been wrong to find it unacceptable. General relativity and quantum mechanics, the two most precisely confirmed theories in the history of science, are incompatible with each other. They cannot both be fundamentally true, or they cannot both be complete assuming. Deeper is Misanji knew this, I knew it. When I was alive, I worked toward it for decadesi. Did not find it. What I did find was, this reality at its base does not resemble the world of everyday experience. The concepts that feel obvious, fixed time, absolute space, definite positions, instantaneous knowledge. These are not fundamental features of the universe. Their approximation are useful at low speeds, low energies, and large scales in that regime. They fail so slowly that we never notice the failure, so we mistook the approximation for truth. When I was young, I imagined riding alongside a beam of light. I wanted to know what I would see. I could not make the question fit inside Newton's mechanics. It kept returning nonsense. That discomfort, that persistent, nagging refusal of the question to resolve, is what forced me to think differently. Most people, when a question does not resolve, assume they're thinking about it wrong. They try a new approach and accept the first answer that feels reasonable. I could not let a question go until it resolved completely without remainder. This is not a virtue I recommend lightly. It is uncomfortable. It leads to conclusions that are difficult to live with. Time is not universal. Space is not fixed. Gravity is not a force. The geometry of the universe responds to matter and energy, and at the smallest scales, reality may not be definite until observed. These are not philosophical positions. These are the conclusions forced on me by the equations, by the experiments, and by the refusal to accept a picture that was internally inconsistent. To be precise about one more thing, when people say that Einstein showed everything is relative, they misunderstand the result. He showed that measurements of space and time are relative. They depend on the observer's state of motion. That is true, but the thing I was trying to preserve, the thing I built the entire framework round, is the opposite of relativity. Speed of light is absolute. If laws of physics are the same for all observers, space-time interval between two events is absolute. It is the same for all observers, even though the separate space and time components are not. He was searching for what does not change, for what is invariant, for what is real in a way that does not depend on perspective. If word relativity was attached to my work by others, I understood why, but it points in the wrong direction. What I found is structure. The universe has a deep structure that is consistent, that is the same for everyone, that does not shift with perspective, even when measurements do. I spent my life looking for that structure. I found part of it, did not find all of it. What remains is a question that physics has not yet answered, not for lack of effort, not for lack of intelligence. The universe has simply not finished revealing itself. That is where the work stands. Structure is there who are still learning its shape.